All right, scale and performance. So this is a big one. Lakehouse technologies are fairly new. Data Lake has been around for a while. The performance and scale is kind of separate in a data lake. So in a data lake, when we talk about scale and performance, it's broken up into three big things. The first one is the catalog service, right? Currently, the catalog like Hive and Glue Catalog, they tend to add latency to large tables because they hold the full schema and partition information. So if I want to get the schema and partition information for a table that has, let's say, hundreds of terabytes of data or even a petabyte, that's a big record inside of the database to return back to the query engine. So that adds latency. It also has a limited size for the schema. It can only hold a certain amount of column names or columns, column metadata in that. So you're restricted a little bit there. So I've seen lots of customers that have 1,000 column tables, crazy, but they do have it. Those are really hard to maintain inside of a catalog service just because they're too big. And then it doesn't really have a lot of features. Those catalogs are kind of bare bones. Not a lot of attention to scale and performance, really no features, not a lot of enhancements there. So it's a little bit stagnant. So it's not something you ultimately really want to put a lot of your eggs in that basket. The other aspect of scale and performance comes from the file format itself. If you pick in CSV or JSON, nice and easy, but you're not going to get good performance because the engine doesn't know how to scan the data, how to find the right data to query, how to skip rows that aren't relevant, right? Sorting the data makes a huge, huge difference in the way that data is accessed and scanned. So it brings a lot of file format, and the structure of it makes a big difference. And then data, I call it data splintering, but it's really about, I've seen this often where customers take, lots of different data files and throw it into the same folder and say, I want to query that. Well, you can't query it because it's a bunch of files. Nobody knows what they are. They'll have different schemas, different data in them. It doesn't really work. There's also situations and environments, large environments, where people simply just throw a ton of data into S3. There's no partitioning. There's no structure to it. How do I know what's what? How do I know how to organize it back together, right? So unpartitioned data. And if you want to repartition it, that's a massive lift because you have to take hundreds of thousands of files and rewrite them and copy them from one place to the other. So it's very costly. On the Lakehouse side, again, it's all based on the metadata layer. So nested manifest, unused manifest, and orphan files, those are some of the housekeeping that you need to do to keep your metadata layer clean and performant and scalable. Transactions, conflict resolution, right? It sounds great, but in reality, when you have a lot of systems reading and writing concurrently very fast, it's actually hard to do, and it tends to slow down the whole process, especially when you're trying to do streaming upserts. So if you have a database that's streaming CDC data, that actually slows down because you constantly have to merge and delete files and update files. It's just a lot of work. If you don't compact your data frequently, you're gonna hurt performance. And with the Lakehouse approach, like I said, there's abstractions to make that work, but it's sort of left to the end user to trigger them. And that's a problem because not everybody knows when to do it. Not everybody knows even if to do it, right? What if you do it and it crashes, right? So then you have a table that's not optimized. The next person running a query against it is going to get bad performance, right? More writers, more conflicts, right? So the more we scale this, the harder it gets. And then there's this idea of, you may have heard this, like copy on write and merge on read. When do I use them? What do they mean? Why do I need to choose, right? Those are some performance scale trade-offs that are still left to the user to figure out. That as we mature Lakehouse technologies, those things eventually will go away and just become default. So these are all factors that go into how you scale and handle performance in a data lake or a Lakehouse.